All right, everybody, welcome back. This is week 5. We're going to start module 3 this week, and this will go for 3 weeks, I think, module 3. This is the meat and potatoes of everything, so it's going to get a bit more difficult here. Please pay attention, read the book. If you don't understand something, ask a question. This week, we're just going to do 3.1 and 3.2. And as you probably can see on your page, there are a lot of labs to do this week. The labs aren't terribly hard, and it's just screenshots to submit. So don't let the amount of assignments fool you. It's a normal amount of work. But we are going to cover quite a bit throughout module 3. And just like like a math class where you learn something and then build on it the next week and build on that the next week. That's kind of how this course goes, and this is how programming goes. So with that, we will jump right into PyCharm. If I can get it open. We are going to cover, in Module 3, we're going to cover Boolean values, conditional executions, loops, lists, list processing, and logical and bitwise operations. But just in 3.1 and 3.2, we're going to go over some of the operators that you'll see. We'll do conditional execution and loops. Maybe cover a break or two. But, anyway, let's get started. So the first thing we're going to talk about is the assignment operator. And we've already seen this. So if you have a variable and it equals 5, the assignment operator is the equal sign. Simple enough. You just need to know that's what we're calling the equal sign, is an assignment operator. Now that is different from the equality operator. So var and 2 equal signs is not the same thing. Oh, let me zoom in here. Fix my screen a little bit. Let me put console up so you can see all that. Okay. So here we are assigning a value to this variable. The value is 5. Here we are asking the question, is this variable equal to 5? I hope that makes sense. We can test this using a Boolean operator. And a Boolean value is either true or false. A statement is either true or false, and that true or false becomes a Boolean. It can only be one of two things. So if I do a print statement, what we're asking the computer here is the variable equal to 5. We're not saying the variable is equal to 5. We're asking, is it equal to 5? And if I run this, it'll come back with true because the variable is in fact equal to 5. Now if I change this to 6, variable 6, we're still asking the question, is the variable equal to 5? And I run that, it'll say false because it's no longer equal to 5. So there we just covered in 2 seconds the assignment operator, an equality operator, and a Boolean value, and you'll see all those. There are some other things, like there is not equal to 5. It's the exclamation point and the equal sign. It means not equal to. Again, we're checking to see if the variable is not equal to 5. And if I run this, it should come back with true because it is in fact not equal to 5. It's 6. So it's true. And if I change the variable back to 5 and run it again, we get false because the variable is equal to 5. And this is asking, is it not equal to 5? So that was real quick and dirty. I hope you understand that. We also have greater than, less than. So here we're asking, is the variable greater than 5? And if I run that, it should say false because it is not greater than 5. It is equal to 5. So if I change this to 6, it should return true. And if I put it back to 5 and I ask a different question, is the variable greater than or equal to 5? And I run it, it comes back true. because it is in fact equal to 5. And if I go to 4 and run it, it should be false because it's less than. I can change that symbol and ask it a different question. Is the variable less than or equal to 5? And it comes back true because it is less than or equal to 5. So those are the other operators, or equality operators. Equal to, greater than, less than or equal to. Use those quite a bit. How would we use that? With an input, let's just say our variable n is going to be equal to the int input, enter a number. And I always put this little space in here just so it gives a little something. And then when we get the user's going to enter the number, I'm going to print whether n is greater than or equal to 100. And we'll run that. It says enter a number. I'm going to say 5 and hit enter. It says false because it is not greater than or equal to. If I run that again, enter a number, and put 101, it's true. So this is how you would use it to gather an input and then check it against something. Let's see. So right here we've been using integers and numbers. You can do this with a string. You take that int and then enter a word. And let's say I have another word. No, I don't know. We'll add special. And then we'll say, we're going to introduce you to if statements here. If W is equal, we're going to use that. No, if N is equal. We're checking, again, we're not assigning, we're checking, we're asking it if is N equal to special, well, then just do W. That is the word, all right? So we're going to take an input from the user. We're going to compare it. We already have our value here. This is our hard-coded variable, our special word. And then we're going to check and see if N, which is the input from the user, and W, which is equal to special, if they're the same, we're going to print that's the right word. And if I run that, it enters a word, and I'm going to say, I don't know, not special. It doesn't do anything because we haven't told it to. If I run that again and do special, that's the word. We get the right word. So this is how you do an if statement. It's just if your conditions, this is conditional execution, this print statement is only going to execute if this condition is met. But we don't want to have it just not do anything. So we're going to add an else. And this is an if-else statement. Not the word. So if I run this, and again, I put in not special, it's going to say that is not the word. So what Python's going to do with this conditional if statement is going to check the first statement, right? If N is equal to W. So if the input from the user is the same as the word we've already specified, it's checking the two together. If it is, it's going to print that's the word. If that condition is not meant, if it's anything other than that, it could be a number, it could be a sentence, it could be one word, then it will go to this else statement and do what is in the else statement because this condition is not met. So that is an if else. Now there's a couple of other things we can do in here. Let's say we want to look for a couple of different conditions. we do what an else if or elif statement. And then we want to add another condition in here. If n is equal to not special, that is the opposite or something. And make sure that you're indenting. So when you do any kind of statement, a loop function or anything, you want to indent. What occurs if this condition is met should always be indented. And then when you're done with what should be done, if the it is, you come back out to the other side. Pay attention to your indents, and you'll see what I'm doing throughout this video. So the else if, so it's going to check and see if the user input is equal to special. If it's not equal to special, it's going to jump down here to this else if statement and see if it's not special, and then do something. And then we can end the whole thing with another else and print that is not the word. So if I run this, and if I type in special, the first condition will be met, and it prints that is the word. And it does not go any further in here. It'll hop out of this to the next line that is not in the if or else if statements. If we run it and we print not special, that's the opposite. So it checked this condition, checked the first condition, and that was not true. So it went to the second condition, and it found that that was true. So it does what the code's supposed to do and says that's the opposite. And if we run that a third time and print, I don't know, pi, it's not the word, it's not special, and it's not special. So it's not the word. It checks the first two conditions, finds them both to be false, and just does whatever else. So that is an if-else conditional programming or conditional execution. Now you can have nested if statements. This is probably the best way to do this, but you could, if it's not W, we can nest this well, we'll leave that like that. So instead of doing the else if, this isn't probably the best example of it, but like, let's do numbers here. Input a number. I'm just going to get rid of all this. Let's mix this up a little bit. And let's make sure that we make this an int because we want to look at numbers here. We'll do values. So if n is greater than 5, we'll print, actually let's do less than or equal to 5, print less than or equal to 5. Otherwise, or else, let's do this. Number between 1 and 10. Less than or equal to 10. So if the number is less than 5, less than or equal to 5, it'll say less than or equal to 5. If it's less than or equal to 10, it'll say 10 or less. So it's kind of the same thing. We could say, let's say we just wanted to if n is equal to 3, and then forgot my little parentheses here. All right. So I think, and I'm kind of running through this quickly without much thought, but I think what this is saying, it's going to look at these numbers. If it's less than 5, it's going to then check and see if it's equal to 3, and then if it is, it's going to print the. Make sure you put your semicolons. Get those little red marks. If it's 3, it's going to print the numbers 3. But if it's less than 5 and it's not 3, it's going to look at this statement. See that it's less than 10 and print 10 or less. Otherwise, it's going to print enter number between 1 and 10 because it has to be greater than, unless they enter a negative number, and we don't want to deal with all that yet. So let's run this and see what happens. Enter number between 1 and 10. If I enter 11, it says enter number between 1 and 10 because that wasn't between 1 and 10. If I enter 4, it's less than or equal to 5, so that works correctly. If I enter 3, it prints both of these are true, right? So it will print this, and if it's 3, if it equals 3, it prints this too. So if you just want it to just print 3, you have to kind of put that print statement up here. This would be probably a better example. Oh, got the else. So this would probably work better. So we have an if-else statement with a nested if-else statement. This is what it means to be nested. There's an if statement within an if statement. Let's try this again. Run that, enter 3. It just prints the numbers 3 because while it does meet this condition, it has to then meet this condition as well. And let's see what happens when I do a 4. Less than or equal to 5. It doesn't print the numbers 3 statement. So this is a correctly done nested if-else statement. What else have we got? All right, so every time I do this, I have to restart the program, type in a number, and then see what happens. To keep a program going, you need to put it inside a loop. And like a good example of this, but in this case, I'll just do a little while 1. And what that's going to do is just continue to run the loop because there's no condition to exit this loop. So this is what we're going to call an infinite loop. It will never end because there is no condition to end it. But if I run the program here, enter number between 1 and 10, 4, okay, 5, 10, you can see the program will keep on going, keep on going, keep on going. The problem with this, it works great for printing numbers 1 to 10. There is no condition that will end that loop. So I'm going to create a variable, and I'll just call it run. You can give it a assign it the value of 1, and then at the end of our if-else statements, outside of the if-else but still inside the while loop, we will let's see, we'll redeclare this variable. We'll try and get another value for this variable run. And we will reassign it to the input in, let's make it int input. Do you want to continue? Quit. Q-U-I-T. Fingers ain't working good today. All right, so here we're going to redeclare this variable. We want another value for this. If he presses 1, it'll stay 1, and the program will keep running. If he pushes 0 or really any other key, it should quit because it's going to change the value of run, and then this loop will not run any further. So let's see what happens when I do this. 4, do you want to continue? I'll push 1, see what happens. Enter number between 1 and 10. We're going to enter 5. Do you want to continue? And we are going to enter, I'm going to put in 2 just to show you that it doesn't matter, but, and then it exits. So that is a good working loop. And this allows you to run, you know, your simple thingy-bobbers programs in a loop continuously, so you don't have to continue. You stop and run these little programs. Let's show you a little bit about time. So in Python, the thing that makes Python, I don't want to say it's a great language. You know, there are arguments for every language out there, but the reason I enjoy Python is because you can use other people's work. There are thousands of libraries out there that people have created for you to use. Like if you've never heard of NumPy, that's a library that you'll bring in to do number stuff. Pandas is great for using Excel documents. Matplotlib is good for plotting data and charts. If you continue to use Python, you'll see a lot of these. But there are also some built-in libraries, and time is one of them. How we use those, it was just go import. The very first statement should be import, and we're going to import time. And the way you use this is we can do, for this one we'll use sleep, right? So here I'm going to do a couple of different things. This is another loop. It's called a for loop. And we're also going to learn about range. So here we got time, we got for, and we got range. This 3 different things we're going to learn with this simple little thing here. So for I in range, we're going to print word here. I hate using your homework, but so here we're going to try and print out the word Mississippi, but we don't want to print it out all real fast. We want there to be a delay, a 1 second delay between each one of the characters, and you'll get to see kind of a program run in real time. It should take MISSISSIPPI. Should take 9, 10, I don't know how many, I just lost count, but it should take that many seconds to print it out. So let's see what happens here. For I in range 5, we are going to sleep 1 second. So this is how, like, you imported time, and then you call the time dot sleep function. So this is the library, for lack of a better term, or the built-in function, or whatever you want to call it, that we're calling, and then inside that is a function called sleep that tells the computer to go to sleep. This doesn't seem right though. Let's run it and see what happens. I got an error. Oh, semicolon. All right, run that. Nope, it just says 1. Okay, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. So I was wrong when I told you what we were doing. This is like counting 5 seconds for the range. Yeah, this would be length. And we'll do that later. You can actually, like if we did len, all right, I'm going to confuse you right here. Don't worry so much about this, but so I just did a few things. Instead of printing just the word Mississippi like we have in this output here, 1 Mississippi, 2 Mississippi, I instead assigned this variable word the value of Mississippi. And instead of using range, so we did range 5. So 1 through 5, it's going to print 1. You see what I did here? The I, for I in Mississippi, then this could be anything, but for letter. So for every letter in the word Mississippi, it's going to do something. So now it's going to be, we had, if we did 4 letter in range 5, well, it wouldn't matter. It just doesn't make sense that way. But the range was 5. And here it's going to be, the range is going to be the number of letters in Mississippi. So for every letter in the length of the word variable, what I have right here, we're looking at the length of the word variable, which is this many letters long. It's going to do something. And then I have to, for letter, I don't think I need to make it a string this time, but because we were using a range that was numbers, what we were doing, we were converting that number into a string, and we were adding, it was I plus 1, now it's letter plus 1, because a computer, this first letter here, the M in Mississippi, the computer will not name it 1, it will name it 0. The computer always starts counting at 0, and that's very important to learn later on when we start doing list indexes and that kind of thing. Actually, probably next week. A list, a word, anytime it counts anything, the first thing it starts counting at 0, where you and I would normally start counting at 1, 2, 3, 4. It's going to say 0, 1, 2, 3. So if you think there's 4 things in it, it's only going to return the value of 3. We'll get into that later, but that's what I've changed. I just added a space here because I can't stand when it outputs 1 Mississippi like this. So I added a space, and then again, this is just a variable word, which should be Mississippi. So let's run this and see what happens. And I get a int object is not iterable. Line 5. It's not an int. Maybe it's... I apologize. I said, this is right. Let's do this real quick. Yeah, okay, so that works. It is iterable. It does count it through. What am I messing up here? Ah, shoot. Oh, I probably didn't need to do the length, but I'm not sure. All right, so I think maybe the length was wrong. And I'm glad I'd like to do these videos and mess up, so if in case you run into the same problem, you can watch me fix it, or kind of just understand how to troubleshoot because that becomes a big deal later on. But so what we've done here, for every letter in the word, it's going to print that letter. So it iterates through this word, Mississippi, and each time, each letter there is going to print it out in a new line here. But if we wanted to do like they did before, 1 Mississippi, 2 Mississippi, we would have to print okay, so what I was telling you before, that length word for letter in length of the word variable, this just gives me a number. That's right. So if I did range, that's instead of range 5, we're going to use the range of the length of the word. So with this length with the word function in here is going to count how many things are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the same as saying range 11. But that way, if the word changes later, if you ask the user for a word, you can you don't have to change this part of the code. So let's see if this works real quick. It should do the same thing. Yeah, okay, now it's just printing number. See, it starts at 0 and goes to 10. That is actually 11, but the computer sees it as 0 through 10. We would see it as 1 through 11. The computer sees it as 0 through 10. So we're going to print the letter +1, +1. So that now, when we add that +1, it'll start counting at 1 and not 0. Plus the space, and then I will do plus word. So just like your hide and seek, instead of 5 Mississippi, this should go to 11 Mississippi. We got to keep our math in here. So in this, it's going to, I know it says letter, but it's actually a number because we changed it around. This should be 1. Oh, and I got to convert that to a string. So this is getting ugly and confusing. I hope you guys can follow here. We have to convert that number, you saw it was 0 through 10, into a string so that we can then use these little plus symbols to concatenate. Now, if I had just used a comma, you wouldn't need to worry about that, but like I said, to use the plus symbol so you know exactly what your output is going to look like. Let's try that again. Okay, so we got 1 through 11 Mississippi, but it did it real fast. So, and we were trying to use time here. So time.sleep. I'll just put 1 second in there. Now, if we run it, it should count 1 Mississippi, 2 Mississippi, 3 Mississippi. And it's working like it should. So we just covered a few things all at once and really fast. A for loop, range, length, and time all at once. You're going to have to figure out how to use this to your best ability or to your advantage. How would these benefit you in the future? I think that about covers it as far as your labs. You will have to do one of your labs uses modulus. I think we covered that last week and even maybe a little bit the week before. just remember, like, 10 mod 2. It's going to print the remainder. So 10 divided by 2 is what? 5? Yeah, 2 goes into 10 5 times. There is no remainder. So the output of this should be 0. 10 divided by 3 is 3 with 1 left over. So the modulus is 1. If I run this, you'll see the modulus is 0 and the modulus is 1, just like I said. Remember, it's not 10 divided by 2. You're not looking to get 5. You're looking for that modulus, or that remainder. So when you do that in your labs later on, just remember that. Again, we've covered that the past previous weeks. I'm not sure I do a great job of explaining it, but it is in your book. And the last thing I want to touch on today is a little bit of GUI, called GUI, Graphical User Interface. That is the thing that you use to interact with any program. In your final, we are going to build one. We're going to do a calculator with a graphical user, so your user can just use the mouse or the keyboard to punch in numbers. I've been told I need to incorporate some of the final exam at intervals throughout the course so that people do better on the final exam. So let's take a look at Kinter. I'm going to import Kinter, T-K-I-N-T-E-R. Now this comes with Python, so you should all have it. All right, actually, when you import Kinter, you do it a little bit differently. We are going to do from Kinter import and the star. So from Kinter import star. And like I said, this is built into Python. You should already have this. You don't have to download anything extra. All I'm going to show you this week is how to do a main window. And like I said, I'm supposed to incorporate some of the things that we're going to do in our final throughout the course, hoping for better outcomes for the final. But this week, all I want to show you is that import Kinter and how to make the main window, the backdrop for your whole entire program. So then we do root equals tk, and that's function, so you got to put parentheses after it. We haven't even talked about functions yet. Another one is going to be root.main loop. And this just keeps the window alive. So if I run this real quick, it will pull up this little window right here. And this is going to be the backdrop for your program. In here, we'll put text, we'll put inputs, we'll put buttons. For the calculator specifically, we'll have lots of buttons that do things when you click on them. But this is how you do this is your first window for any program. And you can think of these like, this is a box, obviously, and there's going to be boxes within boxes. You can set up how they're laid out and how the program looks visually, which is always very important for user interaction, user experience. Last thing I'll show you this week on this is root.title. And we can make this any title you want. Obviously, it should be descriptive as to whatever the program is. But you can change the title on the root window, and when you stop it and then rerun it again, bring it over. So we've got the main window and the title. That's all you need to know. And this isn't for any assignments this week. This is for the final. We're working on it. I may even open up the final week so you can see what's going to be expected. At any rate, please get on this week's assignments early. That stuff, everything I went through was pretty quick. It can be very confusing, and I don't know if I explained it very well, but there are a lot of assignments here. Some of them are pretty tricky. So if you have any issues, let me know. And thank you.